Titanium is a transition metal with many different properties, which are very useful in both common-day uses, such as cutlery, and major uses like your spacecraft. One of the most prominent of its physical properties is its strength relation to its density. While titanium is quite strong, it has a particularly low density, which makes it a very light metal. This is because it has a low mass, but its crystal structure is organized in such a way that it adds strength. Each atom in the structure is bonded to 4 other atoms, which helps in its durability. Titanium is as strong as steel, but much lighter, making it a better choice in things that depend on weight, such as bicycle frames. Most of the time, titanium is alloyed with other elements. This combines the base metal with different elements in order to create new properties for different uses. For bicycles, grade 9 titanium is mostly used for the frames. This alloy is formed out of 94% titanium, 3% aluminum, and 2.5% vanadium. Grade 9 titanium is easier to machine while still having the necessary properties for bike frames, and is also stronger than pure grades of titanium. Titanium has great strength that will be able to handle rough terrains or stress in the bike frame. It also has great fatigue resistance, adding to the durability of the bike. Its crack resistance also helps in defending the bike from dents or other damage. Not only does it allow the bikes to adapt to different situations, but it also creates a comfortable bike that adapts to the user's weight instead of staying stiff. The only other metal that could compare is steel, but titanium easily is better due to its lightweight. Titanium is also perfect for golf club heads. Because of its density, it makes for light club heads, allowing the club head to be larger because of its weight. Not only that, but it also increases spring quality when it hits the ball, making the ball go faster than even a wooden club hit at the same swing speed. This is because the club stores some of the energy, then releases it when it hits the ball. Golf club heads are commonly made of stainless steel, titanium, aluminum, and carbon fibers to help balance the bond. Titanium is great to use in golf club heads because of its resistance to denting, especially in the face. It also has a high tensile strength, so it won't break easily after being hit multiple times, an important quality in the face and other parts of the head. Titanium is also a very ductile material, which means that it has the ability to stretch easily instead of breaking. This is good because it allows the face to be more durable. Golf club heads are also affected by alloying, since pure grade titanium, or titanium that hasn't been alloyed, can't survive the stress of club heads. It is alloyed with other elements. Titanium is also commonly used in aircraft parts. Titanium is useful because it has a high durability and survivability, which is needed in aircraft due to its exposure to immense pressure. It is used in the engine and in the fan blades, pumps, and screens, as well as other places that are around high heat. Titanium has a high melting point at 3000 degrees Fahrenheit, which allows it to be exposed to high temperatures without many problems. It is also used on the outside of the plane, in the landing gear, propellers, and parts of the wings. Titanium alloys are also used in naval ships, missiles, armor, and aerospace craft. Titanium suede is good for military and aerospace uses due to its durability and low density. Titanium's hardness, durability, and low fatigue work great for ballistic threat armor and other military applications like tanks, weapons, and missiles. Most tanks are expected to be made of titanium tungsten alloy for prime protection. Its extreme corrosion resistance is a great advantage in naval ships, especially in piping. It is almost as resistant as platinum and is only affected by specially concentrated acids. This property is due to the fact that titanium is enveloped by a layer of oxide while exposed to air. However, titanium is not perfect, and there are lots of disadvantages to its use. The most major is its expensive cost because of its complex machining process, rarity of pure titanium, and the expectations of the aerospace industry. The aerospace industry depends on a quality and flawless product, while the commercial industry might not need such a perfect product. Since titanium production is tailored to the aerospace industry, its price is higher. Titanium is rarely found pure. It must be purified of its other bonded elements, and as machining is complex since it could crack and bubble due to its high melting point in the welding process, and it could also soften. This all adds to the cost of the material. The solution to this problem will be to form a new machining process, to stop relying on foreign countries or resources, and to create a better extraction process. Titanium is a great element that has many diverse uses, and as time goes on, we will find more ways to use titanium and to eliminate obstacles limiting its potential.